Hello, we're back. We're back with another planetary episode, Anthony. Are you going to get mad at me soon about how many planetary episodes we're going to do in a row here? What do you think?
No, because every time that we do one now, there's like something that I feel a kinship with our guest. I forget what was last week's. Now I'm forgetting entirely what our show was last week because I had podcast amnesia. What was last week's show?
We had Gordon Azinski on last week.
Yes, and what was our thing? Why were we were buds at the beginning of the show for some reason that I forget. No, I can't remember.
I don't remember.
People will remember, but we've got an Italian today who's slowly cooking Italian American food instead of Italian food. Is what we decided right before we went live. I'm gonna fly out. I'm gonna teach you how to cook gravy. Is what I'm gonna do.
Yes. We're here with my friend Stefano Nerozzi. Am I saying that right? How's my Italian?
Yeah.
Nerozzi?
Okay, very good. Very good.
Yes. I'm trying. I always try to be as cultural as I can. So
I guess this was my opportunity to start the show in Italian, and like you've done in French a couple times. That was the chance.
Well, maybe when we get the Astronauticast guys on, you can do that. And then
yes, that's totally right.
Yeah. But yeah, so Stefano, my friend, is here. As you can see by the map of Jezero crater behind him, it's a Mars guy, and I don't have my Mars outlet anymore. So I'm sneaking Mars into the show more and more. We'll see how that goes. So Stefano, welcome. We're glad to have you here today.
Thank you. Honored to be here.
Yeah. What do you want to talk about? Do you have any ideas?
I'm just gonna go through the maps in your background and see why you hung those up.
Oh no, please no, because the map is just there for the looks. And no next to nothing.
That's how you impress the ladies, right?
Yeah, sure.
Yeah. Cool. Well, should we start with some drinks? Who wants to go first?
Stefano's on the lunch break over there, drinking on a lunch break.
Oh yeah.
I feel like
I just finished my lunch and I have a very local beer here, right here, brewed in Tucson, Tour of Tucson. I never tried this, so this will be a first for me. Test. I'm sure it's gonna be good though.
I'm here for the cycling too, Jake. You're just nailing it. You're finding like people that are just synced in with me and introducing me. This is great.
Yeah, well, that's what friends are for, Anthony. I'm just trying to hook you up with good things in your life.
I'm gonna start going to LPSC pretty soon if you keep this up.
Yeah, pretty soon we're gonna have We Martians hosted by Anthony Colangelo.
Yeah.
Bringing it back, baby. When you get that Dylan Taylor money and you decide to just buy my friend,
he's gonna bring your show back. Yeah, it's like when Bezos was like, "I want more Expanse. I'm gonna bring it back."
Did you ever tell him about the Mars house?
Oh yeah.
I've mentioned it a few times. I mean, Mars house is
that's awesome. Yeah. That's
why you and I are friends.
It is. Yeah. Thanks to Cassie.
Mm-hmm.
Cassie was the big bringer of people.
The instigator.
The instigator.
The bringer together. I mean, a lot of friends from the Mars house. It was a fun way to hang out at that conference for sure.
What'd you got? Did you bring something good?
Oh, me? Yeah, well, I don't know if it's good. We're going to find out. But I just got something like real off the shelf today. So this is a Helix hard seltzer.
Look at that.
Pina colada. So, yeah.
Never heard of Helix.
I think it's probably just going to be a White Claw with a Mexican on the side of it. I don't know.
That's good.
Smells
I
good.
got a lollihop. A Trogs lollihop. Is that going to focus? Look at that. Lollihop. Look at those. I like the little lollipops.
Double IPA. What kind of percentage are we looking at here? Are you in trouble today?
Haven't looked. 8.2, and I have a second as well. So I've been cracking this in the pre-show now, which, Jake, I would like to plug because the pre-show people got a good pre-show today. We've been doing this live stream style thing in Discord right before the show for like a half hour, 40 minutes, and offnom.com/Discord. You can sign up and get in it. And today, we probably need your advice on this. We were developing our own asteroid mission. We're working on the backronym so that it can be called the Booze Cruiser. And Jake has this concept. Jake's the PI. It's going to be an asteroid mission that just goes from the inside of the main belt to the outside, as like that's the orbit regime it sits in, and we just cruise through asteroids, and I guess topically, we've got the new binary asteroid Dinkinesh out there that we just got pictures of. So Jake's developing his own asteroid program in the pre-show. That, and we were trying to figure out what shadow government Dylan Taylor is setting up with space media, and I don't feel like we made any progress on figuring that one out.
No, we didn't. We haven't unpacked that 4D chess yet. Yeah. But we're gonna do Mars stuff today, obviously. So I don't know, where do you want to start? So we had a couple Mars topics kind of on the burner. I mean, I really wanted to talk to somebody about Mars sample return because there's all kinds of drama happening there. And Stefano, I always appreciate when you give me
trouble incoming. Trouble incoming. You need to be extremely careful here.
Yeah. So I thought we would talk about that, and then I know you've got some you've done some work on some of the other stuff going on. There's like Mars Ice Mapper, which I feel like hasn't been in the news very much lately, but like it was, like some stuff happened and then it just kind of like nobody talked about it anymore. And I'm kind of curious to see what's going on with that stuff.
There is a reason for that.
So I figure we have some stuff to talk, and we should probably also just talk about what the heck you're working on, because you've always got some cool research projects on the burner. So yeah, I don't know, where do you want to start? Anthony, do you have a choice? I'm Mars biased, so I have to.
I definitely want to hear about Ice Mapper because I was always intrigued by it, and then I have a foggy memory of it getting like backburnered to some extent, and I would like to hear what's going on. Yeah, because it kind of felt for a while like that. Or I'll just be honest, Ice Mapper felt like it was going to be the LRO of humans to Mars. Like it was the one that would get funded first, related to the program about getting humans to Mars, and then it would just be out there doing its thing for years, like LRO has been doing at the moon, and now is finally maybe going to see some humans in its crosshairs. Ice Mapper felt like that, but maybe I had the whole storyline wrong.
Yeah, I don't know. So I maybe it's definitely like, can you just like give us like a broad like what the heck is the mission? And
then... So it must be said that there is an I before the MIM part, the Mars Ice Mapper thing, which is international. So it's really an international mission. It's not just an American NASA mission. It's the Canadian Space Agency is very involved in it. Like they are providing the radar. We can talk about that. Italian Space Agency, European Space Agency, Japanese Space, basically all the space agencies are involved in it.
Most of them.
And and everyone is contributing a piece of the spacecraft and contributing expertise to it. And so when we did the Mars definition team work analysis, that lasted like a good 7 months, 8 months, something like that. It was really people from all over the world. It was not just Americans. It was people from all over the world. In fact, that was an interesting process because we had to deal with all sorts of time zones. There were some very early wake ups, some late meetings, that kind of stuff. And so, yes, essentially, it's a mission that is chiefly based on a radar. Both a sounding and an imaging radar. A sounding radar means that essentially beams radio waves down to the surface, and these radio waves go into the subsurface, and we can look at, for example, the stratigraphy of a planet, in this case Mars, stratigraphy of ice. And it's also an imager. So instead of just beaming down, it can also look to the side and look at how the surface beams back radio waves. So essentially what is being depicted right here.
This is one of my favorite diagrams. I love these diagrams of missions because you're like, is this an orbital weapon? Like, what is this that's happening right here? There's just stuff everywhere. There's a communications network all of a sudden at Mars, which is the whole thing. It's pretty excellent.
Absolutely, yeah. So based on what kind of radio waves like we get back and what they look like, we can determine a lot of the properties of the surface and the subsurface. And in particular case, this was geared towards finding ice. That was the primary objective, is to find shallow ice, where shallow means within the first 10 meters of the subsurface, because it needs to be accessible, right? Accessible to both robots and humans. Still needs to be decided how the ice mining is going to be done. It could be entirely robotic. It could be human guided, absolutely. But it needs to be accessible. So we are looking only at the first 10 meters, really. And the primary objective is really reconnaissance before science, because, I mean, the goal is really to find accessible ice. And then, with all the data that we are collecting for reconnaissance, then you can do a ton of science, of course. And you can collect more data of other kinds that don't necessarily help you with the reconnaissance, but can give you really, really important science for, in this case, for Mars, right?
Yeah. So I think, like, I'm trying to remember how this is set up, but what was weird about this mission was that it was like, it was funded from like the human spaceflight side, like the exploration side. Is that, it was like managed on the science side. There was some weird setup for how it was like organized, and that was
honestly, I don't even remember the details, and I try to distance myself from the economics and politics of this mission, because I'm like, I don't want to get too involved here. I'm trying to limit the potential damage that could come from certain types of discussions and inquiries, right? But no, essentially it's something that came from higher up. Of course, Congress was involved. Yeah. And at some point, Congress also decided that this doesn't sound too convincing, right? That was one of the latest news, not very recent, but that was one development, which is unfortunate, but that is what they decided. Doesn't mean this mission is at an end. Absolutely, in fact, still surviving. It's hanging around. I can tell that after the MDT that happened last year, MDT is the Measurement Definition Team, we convened again in a smaller group this summer to continue the work on this mission, and especially define the secondary instruments that would be very nice to have on the mission. So no, the mission is still alive, still hanging in there, especially because, again, it's an international mission, right? So even if NASA were to completely back out, I mean, the other space agencies haven't said anything. So, I mean, they're all still on board. So, I mean, I guess that if NASA decides to, no, we don't want to have anything to do with it, then the other space agencies can decide, all right, we'll continue on our own. The radar is supplied by the Canadian Space Agency. So the bus, the main spacecraft bus, is supplied by Japan. So I mean, it doesn't all depend on NASA, really.
Name one other Mars mission that NASA pulled out of that still kind of went on with its program. Just name another one. Is there precedent or what? All I'm saying is we'll get back involved at some point. A war here or there, we're back in it.
Which amendment is the right not to answer?
Wow, you are
the right
American
not to say anything.
You're so close to cooking gravy. You're so close.
Yeah.
Never had to use it, but
I find it so like this feels like it's like a microcosm of a recurring challenge that I feel like NASA has, where you've got like part of this community that's like very objective focused on science. Like, we are here to do science, and then to do whatever X science we want to do, we have to buy this and this, get these tools, fly these missions, whatever, spend these resources to get somewhere. And then there's the other half of NASA, which is like, we're here more to explore or develop industry or all these, other like non-science focused things. And every time we try and like blend those two objectives together into one thing, like it's bumpy, like it's weird, right? Like, and I feel like this is a microcosm of that. But we talked about, like last week we had Gordon Azinski on, and we were talking about trying to plan the EVA for Artemis 3. And it's like, well, we're going to get a little bit of time, but this is ultimately like a tech demo, and we gotta handle all these kind of things. There's all this like other stuff that's like impinging on, if pure science was the goal, like you're not going to achieve that, right? And I don't know. I think it's interesting, and I don't really know what the answer is, or like if it's even like, is it even a problem we need to worry about, or is that just like when you have compromises because everybody's working together, you got to deal with that, and that's fine. Like, I don't really know how to feel about that overall, but it seems to come up a lot.
Yeah, I mean, personally, I think it's like it comes from two sides. There's the scientific community on one side, which is contrary to some popular opinion. Not saying everyone thinks like this, but very often scientists are very divided on a topic, right? And this is one case where absolutely there is sometimes a lot of division, or just differing opinions, not necessarily opposing opinions, just different. And in part, you need to keep in mind that everything is funded by the government. And so, sometimes there isn't a continuity in the ideas that flow through the government. So people change their mind both in the scientific sense and the political or economic sense. Absolutely. Yeah. So there's really many facets to this problem, right? And honestly, I think it applies to not only to NASA, it applies everywhere. Really, it's kind of a problem everywhere. I think we tend to hear a lot from NASA. Maybe we have a location bias because we are near or within the US, but I know that the same thing happens in Europe. Absolutely.
Yeah. Although I do think there's like a very specific to a space agency problem, which is like, because the science side of it feel like it's very, the definition of like done on science is like much clearer. It's just like, we need to go and get, these data under these parameters, this many data like over this temporal resolution, and so like you define like, and you're just going to buy that data, really. Like, you spend some money and then you go get the data, and then it's like, check, mission accomplished. Like, it's very like easy to understand when you've accomplished what you want to do. Whereas like promoting the space industry is like so nebulous. It's just like, we're starting commercial LEO to make it so the economy is good, and it's like, okay, like, did you succeed? I don't know. We're gonna keep doing it though, And so like, when you try and marry those two like classes of objectives, like, it's really weird.
Yeah, it's in good part it's a social science problem, which is why lately, in the last few years, like, many institutions are really working hard on this, like on the social aspect of things, right? That's why, for example, scientific outreach is so important. All right. If you can't show the value of doing something, I mean, it could be the most important scientific question in the universe, in human history, that you're trying to solve. But if you don't demonstrate that is actually important, how it's going to benefit everyone, then it's pointless, right? It's not. No one is going to back you up, right? Because they don't know how valuable it is. It's only valuable to you, right?
Yeah, that's how it goes.
Can I ask a question about this report? I think this. I actually found the link to this report. Yeah. So this is submitted to, and it's all the different agencies involved, right, from Italy, Canada, Japan, U.S. So how does this something that happens on any mission, but this one's weird because it's shared by so many different agencies? Or did this come out of the process that you had to give all this information to all of these different agencies, so you wanted to kind of like collate it into one thing to share around?
That's an excellent question. It tends to happen on big missions, or like, for example, or cooperation missions, like Mars Sample Return already got a couple of reviews. For example, one just came out like a month ago, something like that, right? Other types of missions, like especially if it is something that is entirely contained within NASA, so like a Discovery class mission or a New Frontiers class mission, then they will have internal reports and that kind of stuff. Some of them are going to be public, but usually, I mean, at least to my knowledge, I've never really been involved in any other mission except this one. Generally, they are different in scope and sometimes, more focused on maybe on the science or the technology more than in this case, the reconnaissance or the impact on the future parts of the program, right? Because this is only the first step of the program to, send humans to Mars, right? So it's not a self-contained mission; it's part of something bigger, right? It's the first step of something bigger.
Mm-hmm.
Yeah. So there's that additional part of like convincing everyone, scientists, politicians, general public, everyone really, that we need to begin the program, and this is the right step towards walking along the path, I guess. Yeah.
Wow.
So why does it feel like this is such an obvious decision that's then caught in a weird limbo state? Because it's like, it's kind of like, no matter what, if you want to see humans on Mars, or if you just want a really cool follow-up lander mission, or like pick a good spot to send a rover, it feels like this is a pretty. Maybe it's just like a problem with where Mars exploration is at the moment, that we've done a bunch of really interesting missions over the last couple decades, and now we're just staring at the sample return, like black hole that it is in the budget line, and it's gonna eat an unknowable amount of budget between here and when we get the samples back, and until then, we're not really sure what or how to fund anything else. Jay can take it if you want to.
Yeah,
Jay can argue.
I don't really know the answer, so go ahead, Jake.
Yeah.
Here.
Well,
Here.
I mean, some of the things like that I've heard about this was like we got these two sides, right? There's like a team that wants to use this mission to answer scientific questions, and then there's a team that wants to use this mission to build data sets to prepare for human missions to Mars, right? So it's like those are like the two very, very broad objectives with this, right? And there's a lot of places where that doesn't necessarily line up, right? Because maybe the human side is like, well, we need to look at the ice right close to the surface, and then maybe the science side is like, that's not useful to us. Like, we need to go deeper to get deeper history or whatever to answer our scientific questions, right? So then you have this like conflict about what the primary objectives would be. So I don't know, like
we need to go deeper.
Yeah, we need to go deeper.
Their whole report is just the meme.
And then I guess like maybe even just from the human side of it though, like, you're right in that we have had a lot of missions to Mars, and we know quite a bit about it, especially compared to the other planets. We're sort of at the point where if we want to really keep answering new questions, like we need pretty significant, rich, global, high-resolution data sets to like really start attacking this from a quantity perspective rather than a quality. Like it's beautiful to get one sample from one place and explore it in really depth, like a very specific point. But having a global ice map would be very, very good. But that's like, it's almost like I don't know, it's like not admitting, but it's just like you're making the case that we need to move to like a whole new regime of Mars exploration. So it's like a bigger case you have to plead. It's not just like the next incremental thing. It's not like, this is just like what we were doing before plus 10%. It's the right way. It's like reimagine everything. Like now it's time.
This is
the
Kim Stanley Robinson, like the reds and the greens and the blues.
Yeah,
right?
yeah.
This is that. Like, now
Mars. the Mars program that you knew, we did it. We finished that.
The old Mars program can't come to the phone right now. Why? Because it's dead.
We did 20 years from the Opportunity rover to Perseverance, and it was great. We learned a lot, and now we need to move on to the next thing. And it's like, oh, okay, like that's a big.
It's a scary endeavor.
Like, are we ready for that? I don't know. But anyway,
yeah, but it's funny though, because if you think about this in terms of like, if you think about the way that you would if you were someone just getting into this stuff and you were going to Google a series of questions, you would be like, is there water on Mars? Yes. Show me all the water on Mars. That's like the number 2 thing you do, right? Where is it all? That feels like such an obvious thing that then would help all the other things that you want to do in the future.
I mean, we kind of have that, like, to various degrees, like through a like, what's the? Are you on that swim team, Stefano? Like at that
I was involved.
Yeah, like they're kind of just
which distance did you do? 100 meter.
Yeah. Okay. Maybe explain what the heck swim means, so that I don't sound like a complete wacko.
Are you for US or for Italy? Where are you at?
Oh, Italy, of course.
Right. Oh, fine.
I remain true to my origins.
Then you don't get the Fifth Amendment.
Swim is subsurface water ice mapping. Same thing, but by using currently available data sets. So, you try to get out the most that you can with the best techniques that we have available before we send something else to Mars, really. Essentially, it works the same. The goal is the same. Try to identify, in this case, what is the likelihood of finding ice at a particular location. So we used a variety of different techniques like radar, thermal imaging, like morphology or textures, neutron spectroscopy. It's getting fancy. What else?
This is all that crazy derivative science you keep shooting. Every time I meet with you and see one of your posters, you're like, here is something where I deduced through like 17 levels of derivatives that there's all this ice right here. And I'm always like, my brain always melts every time you explain the methods to me. So that sounds like that.
There's really a lot of components that come together, and each component is essentially yields a likelihood of finding ice at a particular place. So then you merge all these likelihoods and you get a final score of how likely is ice to be present within a certain depth on the surface of Mars. And of course, each technique is sensitive to different depths, different kinds of ice. So kind of a complex problem, really. Combining everything together is not as simple as just summing up everything. There needs to be some discussion about like what each specific data set or technique brings to this equation, right?
Big error bars, I imagine, too, right?
Oh, yeah, absolutely. Yeah.
Okay. Well, yeah, so we could do that, I guess. That's the alternative to having this mission.
Yeah.
Sometimes sometimes I feel very Arrested Development about Mars missions. So, like, it's an orbiter. What could it cost? $10. This is how I feel about some of these missions. Like, because when you compare it to any flagship surface mission, you're like, I don't know, maybe we should take a cycle and do 5 of these, and then wait 10 years and figure out what the next surface one to do is. If I'm on a working group, that's what I'm lobbying for the next little bit.
Thanks, Scott Hubbard.
Yeah. How many times can we find water on the surface? Like, come on, let's get some other global data.
I'm guilty.
Yeah. How many times?
How many times have you found water on the surface?
At least one.
Or underneath, right? Yeah.
Yeah,
I don't know. It's interesting. I suppose this problem is not going to go away, right? Like, we're going to be dealing with this sort of conflict of like.
I mean, as long as we want to send humans to Mars, this is going to be the first question you need to answer, probably.
Yeah.
Yeah.
Okay.
My theory is they just don't want to have another LRO because that was kind of strange for a while.
The report or whatever was talking about how LRO was like the model for cooperation between science and human exploration because it
Mission
worked out
great.
so well.
I think the awkwardness was anyone that was higher up than the LRO team explaining what LRO was. Well, so for a while we were thinking about going to the moon in like 5 or 10 years. So we thought, let's build a really high-res orbiter to then pick where we would land on the moon. And then we didn't do it for like 10 years, and we just happened to have enough fuel in this vehicle that we could then use it for the time when we're really actually going to go this time, we think, if everything works out over the next 5 to 10 years. It's an awkward thing to explain over and over again, is my only point.
Yeah.
And a few months ago, I found out that one of the instrument PIs was arrested for espionage.
On LRO? Whoa, I gotta look this up. I gotta do some Googling. Yeah. You got the show for a minute, Jake.
We should have led this. We should have led with this. What were we thinking?
Yeah.
Okay.
Right.
Yeah.
Wait, this was a while back, though, right?
Mm-hmm.
The story, October 20th, 2009. LRO Chandrayaan-1 scientist arrested for espionage. Wow.
Chandrayaan-1.
No, wait.
So
I thought it was Mini-RF. The PI of Mini-RF. No, maybe I'm wrong.
I don't know. Maybe there was a couple. It appears that this person,
Multiple
Stuart David
arrests.
Nozette, was trying to sell details of U.S. missile detection satellites in exchange for cash. So that's pretty good.
Yeah.
He helped conceive the 1994 Clementine mission to the moon. Is a co-investigator on Chandrayaan-1 and on an instrument on the LRO. Wow. Wonder whatever happened to this.
Yeah.
All right.
Oh, they changed PIs and the guy went to prison.
Wow.
Is this going to be the intro to our true crime space podcast?
Yeah. Topical too. He was caught by an undercover officer posing as an agent working for the Israeli intelligence agency. This is a hot story from 14 years ago, whatever.
That's the perfect time horizon for a true crime podcast. But it's all resolved now. And
he's ready to talk about it. Yeah.
All right, we'll get on that.
That's a good one.
Okay. So should we unpack Mars sample return next? Now that we've solved that one.
All right. Hold on, he's working on a memoir. I'm looking at his Wikipedia page. He's working on a memoir.
You'll be on the circuit?
He's going to be on the junket in no time. We got him on this show, 100%. We should bring him on the show and not bring it up at all. Just see if he brings it up.
We're here to talk about Clementine. On Off-Nominal history,
It's pretty wild.
Wow.
All right, well, let's go from Espionage Act to Mars sample return, I guess, Jake. This is a really good segue.
Okay, so I mean, there's lots to talk about with Mars sample return, obviously, but mostly what I want to ask Stefano about is there's huge topic of discussion around whether this is the right expense, because it's a lot of money. It's going to turn into a lot of money, right? This huge thing, and we know that the science is pretty valuable, but I'm finding it very hard to quantify that, and I'm trying to talk to more scientists about it now, just to figure out how valuable is these 18 rocks or whatever it's going to be from Mars, and where as the price goes up, where is the point where your opinion changes from yes to no, it's worth it? that's the question I'm trying to. If it's $1 billion, it's probably a yes. If it's 5, it's okay, I'll think about it. If it's 10, oh no, I'm really thinking about it. If it was 100, you would just say no, right? So I'm trying to figure out where that happens. I don't know. Give me
Jake, what you sound like right now, honestly, it sounds like you're on the highway to an X Prize. How much would a Mars rock be worth? Let's do an X Prize for that. This is how they start.
Nailed it.
If hypothetically an officer from the Israeli intelligence agency approached you, how much would you sell a Mars rock for? Let's establish a price. That's the way to do this, Jake.
That's an excellent question. Honestly, I don't know the answer. I think more than a fixed bar, it would be kind of a continuum where I become less and less convinced about it, and then at some point, like I realize, no, it's not worth anymore. But it's not like, honestly, I wouldn't even know where to begin to assign a monetary value to something like this. I personally know, like, without being involved, I mean, okay, yes, I have a map of Jezero right here, but I've never worked on Jezero, and I'm not planning on working on Jezero anytime soon. So from a scientific perspective, I'm really removed from that specific location. But I can tell you that there's multiple high priority science questions that have been the highest priority or between the highest priority questions in the entire planetary science community for 20 years.
Yeah.
The very obvious one is
every decadal survey. Yeah, I was gonna say every decadal survey has said Mars sample return is #1. Yeah, like literally all of them.
Yeah, and I mean the decadal survey is the scientific community, the planetary science community coming together and decided, okay, what should we do next in the next 10 years? And this happened for 2 decades already. So it's not something they decided one time and then 10 years later, no. No, it has been going on for 20 years. So there is clearly a continuous interest in the scientific community. And I think of course, the number one question is probably, is there life? Probably, was there life on Mars? And I mean, you can devise a lot of experiments, instruments to try and find it, by putting them on the rover. But the technology, the volumes, the mass are limited. Like I've seen instruments like that do one single job, like one simple spectroscopical analysis that take an entire room. They are the size of like a few rovers, and that is one instrument. Can you imagine putting like 10, 20 of those instruments on Mars? No, it's impossible. So at some point, you need to surrender to the idea that either you find evidence right there on Mars with the limited instruments and capabilities that you have, or you need to grab a sample and take it back. Now, doing something like this for an asteroid is relatively easy, not too expensive, fortunately, and so we are doing it, and it's awesome. It's absolutely important. I personally think that the next step is, to grab it from another planet. We grabbed a bunch of samples from the moon. We are starting to grab a bunch of samples from various asteroids, one more interesting than the other. I think the next step is getting something back from Mars. And, some say, well, but we have Martian meteorites. Yes, some of them are even low alteration because they were not exposed to the elements on Earth for too long. The problem is that, we didn't really find anything too interesting life-wise, especially because the type of rock that we got was usually not the right type. Is like a magmatic rock. Volcanic rock is not like a sediment, where there is the maximum likelihood of finding fossil traces for life. Also, we don't know where it comes from, which leads to another big point, which is, besides the question, was there ever life on Mars or in general on another planet, is, besides all the question about, okay, what is the geology of Jezero, another big question that often goes overlooked is, what is the age of things on Mars? Which is a whole different topic, but is still something that is quite uncertain if you look at our estimates. And we might be wrong on ages of geologic units on Mars by a factor of 8. So
I had no idea that this is breaking news to me.
Like some models predict that we could be off by a factor of 8, and there is no way to know how much we are, correct or not, unless we bring a sample back and we do radiometric age dating like we did on Earth, and we do all the time on Earth, or we did for the lunar samples. So if we think that Jezero crater might be 3 something billion years old. I don't know. It could be 8 times younger, as far as we know. So there could have been a lake on Jezero that was like until like, I don't know, a few 100 million years ago. We could be off by that much. Or personally, I don't think we are that far off. There are other estimates that are much more optimistic and say we are off by a factor of like 2. Still big time.
Like
pretty big.
Yeah.
still big, right?
Half the Earth's life.
Yeah.
Huh.
I mean, it's not just one single question. It's not just the life question. Is many other questions that apply to other places on Mars, and arguably also other planetary bodies. Because if we can correct and judge and understand how wrong we were, if we were wrong about the ages of surfaces on Mars, then we can correct our models for everything else, right? For Mercury, Venus, any other moon, right? So it's also important for planetary science in general, for other planetary bodies. The impact wouldn't be big, but still, it would be an impact. Absolutely.
Yeah. I had to think about when we brought the samples back from the moon, like that was a watershed moment for planetary science. Like everything, changed because it's the first time you get rocks back from a different body than Earth, right? And so like your sample size goes from 1 to 2, which like literally like doubles your confidence. Like, so like all, the exact same, how all these models like just like realigned themselves and all went in, and now that we have this sample from the moon. But like sometimes I wonder, like, was it really like a sample size of 2? Because you have the moon that a leading theory of the moon is that it was just like when something hit Earth and it like broke apart. So it's like kind of like Earth as well, and it lives in the same part of the solar system. So like the solar system environment between Earth and the moon is pretty much the same, like at a solar system scale. So like it's kind of like n equals like 1.6. Like it's like kind of like a little bit different. We need to get that full other different planet from a different place kind of situation to really turn the models on their heads again. So like that's kind of how I think about it sometimes, but I don't know.
Absolutely. I think you're absolutely correct. Yeah.
So we've established they're important. Okay, so the other big question about Mars sample return that everyone listening is probably already screaming at their phones for us to ask was just like, is this the right like technical path to go down, right? Because we're building this like very specific one-time use, like very bespoke, with all these international partners, with all these like one-time pieces that fit together in this very complex puzzle: landing, launching, rendezvous, return to Earth, right? And it's going to take us, we're not going to see these samples. I used to joke a couple of years ago that when the decadal survey was coming out, it's like, yeah, this decadal survey is going to talk about the next 10 years. And they're going to say something about Mars sample return, but not much. But these samples are going to take so long to get back that the next decadal survey still won't be able to take into account what these samples did. It's going to be 2 decadal surveys from now before they can go, well, now that we learned this from Mars sample return, here's where we think we should go next, right? Like it's a long, long horizon. So my question is, is this the right technical path to go down, or should we, like, fundamentally, should we just wait for technology to get better and then, do other stuff in the meantime and then come back to this? How do you, as a scientist, make those decisions? Like, when do you wait for technology and when do you just say, we're going to invent it right now and do it? Like, that seems like a really hard question.
As a scientist, I would tell you, ask an engineer.
Yeah. But like when you're not like the PI of Mars sample return, but you still have to like buy these products in a sense, right?
No.
And so...
as a matter of fact, I've always said that an interest in the engineering side of things. I try to put myself in the crossfire between scientists and engineers. Be right there on the spot. I mean, I think that, looking at the technology that we have, I think we can do it.
Yeah.
I mean, we just need to send a rover that is going to fetch the samples. We can do that. I mean, we have already sent many rovers with arms. Some landers have a scoop. Sure. That's good.
We've fetched all sorts of stuff.
That is, I think, pretty solid. We need a spacecraft to bring back something. You may realize I skipped a passage a step here. That goes in orbit around the planet, and then at some point it comes back to Earth. We have sort of done this. There is precedent for spacecraft that were orbiting the moon, and then it was redirected to visit the Halley Comet. This was done like 30 years ago. Yeah, the IC mission. It was orbiting the moon, doing science on the moon, and then they realized, oh no, we can do a bunch of science on the comet. Let's go to the comet. So it redirected the spacecraft. And I mean, we have multiple examples now from OSIRIS-REx, the Hayabusa missions, like orbiting asteroids and then coming back from Earth, to Earth and putting the samples on a capsule, and the capsule lands. We have that is also, I think, pretty solid. The missing step, arguably
the helicopters.
The most
you forgot
difficult.
about the helicopters. This one. I'm thinking this one. This is the helicopter I would recommend.
We need helicopters.
Yeah, this would work on Mars, I think.
Helicopters are working.
You forgot the helicopters.
Yeah. Helicopters are working, right? So helicopters are working. If you don't want to use a rover, just use an helicopter. Put a hook or something.
My favorite word. Just use a helicopter. Just use a little helicopter.
Yeah. The difficult step is taking the sample from the surface and putting it in orbit around Mars. This is something we have never done on another planetary surface. We have done thousands of times now on Earth, but we have never done anywhere else. That is a scientific challenge for which I think we have the technology, but we lack the expertise. We simply because we have never done this before. That doesn't mean we shouldn't do it. I mean, all the time we are doing something new that we haven't done before, and very often in planetary science we are successful with it. So I think we should try. I think we have the technology. We just need to sit down and work on it and do our best to make it work, right? And I think, I mean, honestly,
Christmas party.
Which bangers though. So.
Which really translate this problem, I think, from an engineering complexity problem to an economical problem. Essentially means spending money, which is essentially why Mars Sample Return is getting more and more expensive. That's the issue. But I mean, it's not the only program that is getting expensive. Every single program is getting more expensive. Look at basically every single mission. Europa Clipper, Artemis, SLS. I know every mission has Star or James Webb. I don't know. It doesn't have even to be strictly planetary science. It starts with one price tag, and then realize, it's actually much harder to do than we thought, and we need more money to do it. And I mean, what can you do about it? It's the nature of these things. When you do something new, when you push the boundaries, it's always difficult. You're always bound to find new challenges, right?
Mm-hmm.
Your description made me realize that in the most recent architectural revisions, they doubled the wrong part Like the 2 helicopters and a fetch rover thing is not at all the part that any of us are worried about, and the rocket to orbit is. And like, not sure if you checked on the reliability of the first time you launch a rocket, like just here on Earth. It's never good. I'm like, maybe we should have doubled that part. That seems like a part maybe we should double.
They're going to turn this thing into like a SAM launcher.
I think there is a reason for that.
It's the really expensive part, so it would double the budget.
No. So unless you launch the rocket, like one rocket the first time without a sample in and just look at how it goes, and then if it goes bad, they're like, no. The second one is not going to launch. We need to send a new one. Okay. Otherwise, I mean, if you put the samples on one and then it fails, your samples are gone. Yeah. So, I mean, maybe you can put like half of the samples in one rocket, the half of the samples in the other one. Or again, you can do like one as a test.
We'll pick them up later. I mean, at that point, straight up, at that point,
sample. That's the contingency sample, right?
No, but at some point, right? Like I'm probably not the most optimistic person on the timeline of humans on Mars, but at a certain point in the development life cycle of robotic Mars sample return, you hit the inflection point where you're now just closer to humans, either picking up those samples or their own. If everything goes well in space, like there is that point in time somewhere in the future. So the math that you have to be doing is like trying to gauge that timeline as well and saying, have we jumped the shark and we're now closer to a person picking this thing up? I don't think we're on that end of the spectrum yet. Like some people think, oh, next decade we're ready to roll. I'm like, we're not even going to land on the moon probably until the 2030s at this point.
Yeah.
No.
But it is, 20 years down the line.
That's like human exploration of Mars. That is, I think, one challenge for which I don't think we have all the technology yet. Just the trip to get there is an issue. Without even landing humans on Mars or having them depart. It's just the radiation shielding, having humans on confined space. Okay, yes, we have the space station, but the space station is right there. They know that they can, if something goes wrong, they can come back anytime. They can chat with their family and friends all the time, with mission control all the time. When you're halfway to Mars, the delay time is going to be 5-10 minutes. If something goes wrong, that's it. So,
I mean, what's ever went wrong with launching a rocket on very soft dirt? When's that ever gone poorly?
Yeah. Or
has that been okay?
I wonder if there was ever a human exploration mission to another planetary body where something went wrong.
Yeah. First, like time or two, first one or two is fine. You get to the third, things start to go haywire.
Yeah.
But it is interesting to think about because at some point, right, between now and forever,
absolutely,
there is a point when you're closer to humans picking stuff up and getting back.
Yeah.
Which is like in my view, should be clarifying to the architecture to say, we have to keep this simple enough that we never approach that point. Because if we've approached that point, I feel like then the humans to Mars part is forever away. If we're gonna stumble that poorly into that timeline of Earth, I don't even know how far away humans on Mars would be at that point.
Yeah. That's kind of how I've always thought about it too. And this, sure, I'll do the callback to the beginning of the show. Basically, it's just like when you're weighing like the scientific objective, get me the rocks, versus like the more nebulous, like develop the industry so that we can send people to Mars. Like you're trying to like measure which one's easier and when are they going to take, So like at some point, like this, the scientific community, which is like our interests are the science part of it. They have to be like, well, look, like I don't know how long it's going to take to have a fully functional starship where I can just go to Mars and get the damn rockets myself. Like it's coming at some day. I don't know when it's going to be. I can do this now, and like maybe it's not like the best investment, but you know what? Like sometimes I just buy a pizza and eat a pizza because I'm hungry and I need a pizza, even though it's not the most long-term best decision for my health, or it's not the cheapest option, or like not, sometimes I just eat a pizza. Like so that's kind of how I think.
You want to buy the pizza sample return?
We got lots going on. Let's get a pizza.
I mean, and a middle ground, though. Stefano was telling us rooms full of instruments to do a job. It's like, I mean, we're going to practice landing Starship on Mars a couple of times before humans are landing on it, and that's about a room-sized thing. So, like, can we just fly those 10 rooms there, and 9 of them will make it? and then,
maybe.
You know, let's see what happens when we get to that. And the crane lifts the whole room down, you know?
Stefano, how much does a room-sized spectrometer cost?
It's a room. I mean,
yes.
You know, it's one room.
Yes, it costs.
Yeah. Yes.
It's ENIAC in the Starship. That's good.
I recently, a few months ago, I was visiting one of these instruments. It's essentially a particle accelerator, and there's like, I don't know, 3 in the world.
Low budget items, yeah.
There's like 3 in the world. Each one is kind of a prototype of itself. Like each time they build a new one, it's different from the others because they learn.
Now
something
you've got
new.
NASA's attention.
So like it's, I mean, yeah, you know. Sure, you can put a bunch of these instruments on Starship, but one could also make the other point, like, okay, to understand how to land a Starship on Mars, even as a test, maybe you should understand how to land a rocket to send sample back to Earth on Mars and then launch it back, right? There's a lot you can learn from both the landing and the departure, you know, the takeoff, to then practice with Starship or whatever, and then practice them with do with humans, right? I mean, it's let's look at the moon. We, before sending humans to the moon, we sent a bunch of landers and rovers, right?
Yeah.
So we practice with it.
All right, solved it. We solved
nailed it.
Mars ice mapper, and we solved Mars sampler.
Solved it.
1 hour. See, this is the kind of productivity that someone like Dylan Taylor would like to.
We have never been approached by Dylan Taylor to purchase this podcast.
Next time the president reviews the NASA budget, or Congress reviews the NASA budget, just send them this video.
Yeah, it's us 3. It's us 3. We're there. Yeah, a Canadian, an Italian, and an American. We're good. We got it.
Perfect.
It's all the good opinions.
The International Mars Ice Mapper mission.
We got it. We got it covered. Yeah. I mean, you joke, but I think sometime between now and when Jake and I are done being present in the space industry, we're going to be on some review board. I'm convinced. That's my goal for us, Jake. We're getting on the review board of something. I don't know what. I don't know when. That's my goal.
I mean, technically speaking, we are doing outreach, and we are talking to the general public about the importance of science exploration.
Yeah.
So
put us on. Yeah. Put us in, Coach.
I mean, you don't have to be in the report. This is the report itself, in a sense.
So meta. So meta and uplifting.
We can offer significant savings to NASA and Congress for our reviews.
Yeah. Don't tell Dylan.
Oh, wow. Okay.
A good deal.
Well, what do we got coming up next week, Anthony? I'll put you on the spot. I already know. Should I just say it?
You already know, because it's just continuing this whole thread, Jay.
Yeah,
we've been on the beat for a little bit.
We're doing 3 in a row, 3 planetary episodes in a row. So next week, another close friend of ours, Tanya Harrison, is coming back to the show. We love Tanya around here. She's up to some crazy new planetary science endeavors up in Canada. So she's back in Canada now and doing all sorts of fun stuff. So we're going to learn about what she's working on. There's some new news.
New news. That's a
new news.
Once again, Travis and Jason Kelsey make an appearance on this show, Jake, and you don't even know it. You just reference the thing that they do, and you have no idea who these people are. I have a riddle, Jake. I have a riddle for our listeners to noodle on. The next 3 shows, the next 3 Thursdays, I should say, have a T involved. We've got Tanya, a T, and Thanksgiving, and everyone can figure out what the middle T is, and they'll be pumped. So this is a little riddle, Jake. We'll see if anyone can think of it by next week when we tell everyone what's happening the following week, too.
Send us your T's.
Send in your T's.
T's your T's.
That's good. Better than I planned it.
We're T's and T's here. Yeah, 2 T's.
Stefano, where if people are like, man, this guy's the best, what can I do to follow along with this guy? Where are you sending people?
That's a good question.
Yeah, hit us up with a link.
It's an excellent question. I am very inactive on Twitter, the X thing, whatever. Very inactive, so I mean, you can follow me there, but you're probably not gonna see much. I'm somewhat active sometimes on Reddit. I tend to navigate the space subreddit, the science subreddit. So you maybe see me there sometimes. I have the same nickname as on Twitter, Micascisto, which is the Italian for Micascist.
So good.
I can write it in chat. I have the chat open here. Otherwise, that's it really.
Nowhere.
I have a personal website that I haven't updated in ages, but I keep promising myself I need to update. And of course, I mean, feel free to contact me on any platform, or you can find me on the University of Arizona website. I think there is an email contact there. You can contact me, of course, absolutely. Happy to chat with anyone.
You do deliver on your Reddit profile, I will say, because the first thing that I see is you recommending where to get good pizza on the Italy subreddit. So you've definitely delivered on that. Like, just perfect. Could not have been more perfect. Too good. We got to end the show right there.
That's it. Stefano, thanks for hanging out with us.
I tend to be active on the Italian subreddit as well.
Yeah. See you later, everybody. Thanks for hanging out.
Bye everyone.